In this lesson, we are going to work on optimization. In optimization, we want to maximize or minimize a function with some restrictions. We usually have a real-life scenario, like maximizing the income, maximizing the profit, maximizing the area, or minimizing the cost, minimizing the perimeter, and so on. And we have some restrictions. For example, let's assume we are looking for two non-negative numbers whose sum is 18 and whose product is a maximum. This can be written as maximizing x times y if we represents the numbers with x and y. X plus y equals 18. X and y greater or equal than 0. This is the function that we want to maximize, and these are our restrictions. This can be converted as maximizing p equals x times 18 minus x when x is between 0 and 18. From these restrictions, we know y equals 18 minus x. Therefore, p is x times 18 minus x. Since x and y both are greater or equal than 0, x must be between 0 and 18. So we deal with maximizing a function on a closed interval. Use the derivative to find the maximum. Another example, let's assume we have 200 meters of fence and we want to have a rectangular shaped land across a river with maximum area. Let's assume x and y are the dimensions of the land. We are looking for maximum of x times y. X plus 2y is the amount of fence, which is 200 meters. X and y should be greater or equal than 0. This is equivalent to saying we want to maximize y times 200 minus 2y when y is greater or equal than 0 and less than 100. Again, we want to maximize a function on a closed interval. Another example, let's assume a rental car company rents a car $40 per day, and they have 60 cars, 60 clients. For every dollar increase in price, they lose 1 client. What is the best price? In other words, what price generates the maximum income? The income is 40 plus x times 60 minus x, when x is the number of time we increase the price by $1. So if you increase it x times, the price would be 40 plus x, and we lose 60 clients. This income can be written as 2,400 plus 60x minus 40x, 20x minus 2x2. We are looking for maximum of this function. Again, we are dealing with maximum or minimum of a function. As you see, what we do is converting the problem to y equals f of x when x is in D, and D is a subset of real numbers. Let's solve one question completely. Sum of two non-negative numbers, x and y, is 20. Find the numbers if sum of their squares is a minimum. Again, y is 20 minus x. Therefore, s can be written as x2 plus 20 minus x to the power of 2, which is 2x2 minus 40x plus 400. X and y are greater or equal than 0. That means x is greater or equal than 0 and less or equal than 20. Because if x is more than 20, y would be negative. We find the derivative of the function for x minus 4d. We set it to 0 and we find the critical numbers. We are looking for maximum minimum on a closed interval. Therefore, we find the value of our function s at endpoints 0 and 20 and critical number. When s is 0, f of x is 400. When x is 10, f of x is 200. And when x is 20, f of x is 400. This means when x is 10, minimum of s is 200. When x is 10, y is also 10. This means among all non-negative numbers, two numbers with the sum of 20, the sum of their squares is minimum when x is 10 and y is 10. Thanks for watching.